Hi guys, Mrs. Delisin here. Welcome to another lesson of Algebra 2. Today we're going to be learning how to solve quadratic equations with complex numbers or complex solutions. And I am going to be assuming that you've already watched my video about how to complete the square and you've already watched pure imaginary numbers video. Because if you have not done that yet, you are going to be confused with this entire lesson. So let us do the first example. You have x squared plus 4x plus 11. And again, the first step is to get your b value. So this is our a value, which is 1 in 1x squared. Our b value is 4. Our c value is 11. Just a reminder. And so if I have to do b over 2 divided by 2, b divided by 2 squared, you're going to get 4 divided by 2, right? Because our b is 4 squared. And so this is 2 squared, and that is a 4. And so that number right there after the 4x is supposed to be a 4. But because it's not a 4 yet, our job is to get rid of the 11 so that we have a space to put the 4 in. That makes sense? So we have x squared plus 4x equals negative 11 because you have to subtract 11 on both sides. Then you're going to have to put the 4 to complete the trinomial. So you have to complete the square. And then that's because you added 4 on your left side, you would also have to add 4 on your right side. And so you're going to end up with a negative 11 plus 4 in the right side, and that is negative 7. And then you're going to factor this, and that is x plus 2 and x plus 2. And we've known that if you have an x plus 2 and x plus 2, you can just combine them and write them as x plus 2 squared. And then you continue with the square root of with a negative 7. And then, because you're trying to solve the equation, you would want to leave x by itself. So you're going to square root both sides. You'll have x plus 2 equals plus and minus square root of 7. And x plus 2 equals a. If this was a square root of a 16, that would have been a 4. If this is a square root of 25, it would have been a 5. But 7 is a prime number, right? So there's no factors of it. So you're going to leave square root of 7 as square root of 7 in the final answer. But because that's a negative, we've learned in our previous lesson called pure imaginary numbers that whenever that happens, all you have to do is to convert the square root of a negative 1 into an I. That's an imaginary unit. So our answer here is I square root of 7. And the last step would be to subtract 2 on both sides. So your final answer would be negative 2 plus and minus I square root of 7. So in our blank here, our answer is I square root of 7. Again, your answer could be negative 2 plus and minus square root of 7 and then I onto the right side. But I remember I said that previously that I don't recommend that because you're going to end up putting the I inside the radical, and that is wrong. Okay, moving on. Let's have another example. We have a negative 6x plus 25 equals 0. Again, your first step was to get the b value. So you have negative 6 divided by 2 squared, negative 3 squared, that's a 9. And this is supposed to be a 9. So because it's a 25, we need a space for the 9 to come in. So we are going to move the 25. So x squared minus 6x equals negative 25. X squared minus 6x. And then you're going to add 9 in here. Because you add 9 on your left, you add 9 on your right. And this is x minus 3, x minus 3. equals negative 25 plus 9 is negative 16, right? And then you're going to be x minus 3 squared. That is equal to a negative 16. Moving forward, let's change the color so we don't get confused. We have x minus 3 equals plus and minus square root of a negative 16. And luckily, we have a square root of a perfect number, a perfect square. So that is just x minus 3 equals. If that is a square root of a positive 16, I would have a 4, right? 4 would have been the answer. But because this is not the square root of a positive 16, it's a square root of a negative 16, our answer would be 4i instead of just a 4. And our last step, again, is to make sure that x is alone. So we have to add 3 on both sides. So this is x equals 3 plus n minus 4i. So 3 plus n minus 4i is our final answer. And of course, because these two are different terms because the 3 is not an imaginary number, so I could no longer combine them, and I'm just going to leave it as is. 3 plus and minus 4i. And some people, they write this as 3 plus 4i and 3 minus 4i. And that's okay. That's perfectly fine. But I usually just combine them. Okay. Next example, number 2. Oh, this is something new. There is an a value that is not equal to 1. You have an a value that is equal to 2. So whenever that happens, that we have an a value, your goal is to eliminate the a value. So we are going to divide this by 2. Would that work? Let's try. So you have x squared plus 8x plus 20 equals 0. Oh, it works, right? They all can be divided by 2. And now the 2 is gone because 0, oh, I also have to divide that. 0 divided by 2 is 0, so the 2 is now gone. Done deal. Now, let's move forward on b divided by 2. Should I still show that to you guys, or you guys are okay with that? B, this is the last time I'll be showing, hopefully. B divided by 2, 8 divided by 2 squared. 4 squared is 16. So that means you're adding 16 on both sides of the equation. But before that, we are going to eliminate the 20. So we have x squared plus 8x plus 16. I got the 16 from here. Negative 20 plus 16. And you know how sometimes you can just write x plus 4 squared right away because you already know. Yep. And so what's that? Negative 4. Ooh, we're going to end up with a perfect square again. X plus 4 squared equals negative 4. Square root both sides. You have x plus 4 equals plus and minus the square root of 4. And because I have a perfect square, luckily I do, I'm going to just do plus and minus instead of a 2. If this was a square root of a positive 4, my answer would have been a 2, but it's a square root of a negative 4, so my answer is 2i. And so final answer would be x equals negative 4. You would have to, let me put that in red. Subtract 4 on both sides. So your final answer is x equals negative 4 plus n minus 2i. Negative 4 plus n minus 2i. Okay, number 2. Ooh, 2 more examples. Can we divide everything by 4? Let us try. Divide by 4, divide by 4. Yep, it works. So you have x squared minus 6x minus 3 equal to 0. So you have x squared minus 6x. I am not going to be doing the b divided by 2. I am going to be assuming that you already know. So I will add 3 on both sides. So I'll have a 3 plus 9. And hopefully you know how I got the 9. That's just b divided by 2, square the answer. So this is x minus 3. X minus 3 equals 12. Okay, and then I have x plus 3 squared equals, oh, wrong. X minus 3, sorry, equals 12. Moving on, you'll have x equals, I am doing too much shortcuts, right? X minus 3 equals plus and minus square root of 12. And square root of 12 is not a perfect square, unfortunately, but we can make a tree, and I already taught you guys how to make a tree. So you have 4 times 3 is 12, and that's 2 and 2. Double go, you already know, right? Double go out, single go in. And this is not a square root of a negative 12, so there is no I involved in our final answer. So final answer would be add 3 on both sides. So you have 3 plus and minus 2 square root of 3. Okay, that makes sense? Easy? Hopefully it's easy. Let's have our last example. Unfortunately, this example has a fraction in there. And usually you guys freak out about fraction. So we have 1/3 x squared minus 2x plus 5. Technically, we have to divide the whole thing by a value, right? So divide by 1/3. That is too much to think, right? Dividing by 1/3. So dividing by 1/3 is equivalent, or it's the same as multiplying by 3. So instead of me dividing by 1/3, which you could do, 1/3 divided by 1/3, negative 2 divided by 1/3, 5 divided by 1/3. Instead of doing that, I'll multiply everything by 3 instead. Okay, so if multiply, how do we, there you go. There you go. So I'm going to multiply, because I multiply 3 onto the other side. So of course I'm going to multiply 3 onto my right side also. So 3 on both sides. So what are we going to do? So 3 times 1/3, that's a 1. So that's an x squared. 3 times negative 2 is negative 6x. 3 times 5 is 15 equals 0. Not that bad, right? Easy. So instead of multiplying by 1/3, you can, instead of dividing by 1/3, you can multiply by 3, which is exactly the same. So 6x equals negative 15. X squared minus 6x plus 9. Hopefully you already know why I'm adding 9 on both sides. X minus 3, x minus 3 equals negative 6. Negative 15 plus 9 is a negative 6. And then I will go x minus 3 squared equals negative 6. Moving forward here, you have x minus 3 equals plus and minus the square root of negative 6. Can we still simplify 6? Is there a double going on? 6 is just 2 and 3, right? So no double going on. If this was an 8, 4 times 2, yep, I could have simplified, but 6 you cannot. So you're just going to leave it. But there is a negative, so you're going to get rid of the negative, and that's negative 1 means, the square root of a negative 1 means I. So our final answer would be 3 because you're adding 3 on both sides. So you have x equals 3 plus and minus I squared of 6. Okay? I'm hoping that this topic is easy and that it this video would help you understand how to solve quadratic, how to solve equations using completing the square. Thank you for watching. I will see you on the next video. Bye.